Hello students, in this video we are going to discuss the remaining part of the fruit. Okay, in the previous video we discussed the different types of fruits, and there we discussed only the flow chart. And now we will discuss in this video the details of those fruits. Okay, so we have classified the two fruits into three types: simple, aggregate, and multiple or composite fruits. Simple fruits will develop either from monocarpellary or syncarpous gynoecium, and aggregate fruits develop from apocarpous gynoecium, whereas the multiple or composite fruit will develop from the entire inflorescence. Okay, now among the simple fruits, you will find two types here based on the nature of the pericarp. So, if the pericarp retains the moisture even after detachment from the plant, then they are called fleshy fruits. If they lose moisture even before detachment, then they are called dry fruits. And the fruit wall is technically called as pericarp. And the pericarp in the fleshy fruits can be differentiated into epi, meso, and endocarps. So, and the nature of these three layers will be different. Based on that, they are further classified into these six types, like berry, hesperidium, pome, pepo, drupe, and balausta. So, in the berry fruit, the examples you just remember: tomato, brinjal, capsicum, guava, grapes, and also dates. Okay, and in all these fruits, berries, generally the entire pericarp along with the seeds will become edible. So, the epicarp is generally membranous, and the meso and endocarps fuse to form a pulp. So, these are pulp bearing fruits. Okay, so everything is edible, and remember when when we see these fruits, tomato, brinjal, capsicum, guava, and also grapes, seed bearing grapes. Okay, you will find many seeds. So these are all multi-seeded berries. Whereas in date, of course, you know that there is a single seed. So single seeded berry example is dates. Okay, like that. And let us come to the next one, hesperidium. And this hesperidium fruit is a characteristic fruit of the citrus, all citrus fruits. Okay, oranges, sweet lemon, and lemon, all of them belong to the genus citrus. So that's why we call them as citrus fruits. In all these citrus fruits, you will find a leathery epicarp. So this is epicarp, which is leathery, and you will find one white layer, that is mesocarp, that is papery, and this is endocarp, which is which divides into what different compartments. Okay, and encloses many juicy hairs. So juicy hairs. So what are edible in this fruit are juicy hairs. That is hesperidium. Okay, and I hope you are able to identify these things. This is tomato, brinjal, guava, okay, capsicum, grapes, and this is citrus fruit. Okay. Now let us come to this third one, poem. And this poem example is apple. And here I am not talking about the pseudocarp. So I am talking about this one. This is the poem, the true fruit. Then what about the one which we eat actually in the apple? So that is pseudocarp, developed from the thalamus. Okay, so that is what the poem. And the example for pepo is cucumber. That means all cucurbits will have this pepo fruit, and it develops from tricarpellary, syncarpus, inferior ovary. Okay, and with parietal placentation. So you can see the seeds here attached to the inner wall of the fruit. So that is why parietal presentation. So what is generally edible here is the meso and endocarp along with the placenta. Meso plus endocarp along with placenta is edible in pepper fruit. Okay, and now let us see the fifth one, drupe, and these are stone fruits because in these the endocarp is stony endocarp. And if you take this coconut and mango, the mesocarp and the epicarps will have different natures. So here this is what mesocarp, which is fibrous, and the epicarp is leathery. And this is mango fruit, and in the mango, this epicarp is leathery. Mesocarp is pulpy or juicy, and this is endocarp. Okay, enclosing the seed. This is seed. Okay, so and this endocarp is stony, and here also endocarp is stony. So, presence of stony endocarp is a characteristic feature of the fruit drupe. Okay, and of course, remember in coconut, what is edible? It is not the fruit layers that are edible, it is the seed, that is endosperm is edible. Endosperm is edible, and suppose if even liquid is present, that is also endosperm, liquid endosperm, that is drinkable. Okay, so like that, and in mango fruits, generally this miso and okay, mesocarp is edible. Mesocarp is edible in mango fruit. So like that. And we have this balausta, and the example is what pomegranate, and it develops from multicarpellary, syncarpus, multilocular, inferior ovary. So because this is what calyx, persistent calyx, you will find even after the formation of the fruit here. And we know that whenever we open it, you will find many seeds which are attached to these placenta. Okay, and the seeds are edible, and of course the seeds will have a succulent testa. So the succulent testa is edible in pomegranate, and the scientific name of that fruit is balausta. So all these are examples of what fleshy fruits. So now let us say these dry fruits, that is simple dry fruits, and in that three types you will find here: dehiscent, indehiscent, and schizocarpic. That means these dehiscent fruits, whenever the pericarp becomes dry, okay, the pericarp will break open and release the seeds. So this is called dehiscence. That's why these are called dehiscent fruits. Under dehiscent fruits, we have five types. One is follicle, and it dehisces only on one suture, that is on the ventral suture. Only on one suture it breaks, and of course here these fruits generally, that means the follicles appear among aggregate fruits. Means what? Like example, magnolia. But when we are talking about individual one, it is a follicle. Okay, but the whole cluster developed from single flower due to presence of Epocarpus gynoecium. And now when we come to the second one, legume, which is a characteristic fruit of Leguminosae family. Actually, that family Leguminosae is named after this fruit legume. And of course, we have one family, there is Fabaceae family. So Fabaceae is the example. And here, of course, I drew the diagram of okay, peas, sweet pea that belongs to Fabaceae. And you can see this is ventral suture and this is dorsal suture, and it breaks open on both sutures. Okay, in from top to bottom, like this, descendingly, and you can see that it is opened on both sutures, and you can see that marginal placentation here. And of the siliqua is the characteristic fruit of Brassicaceae family, and I am taking mustard here, and you can see that this also splits open on both sutures, but ascendingly. And but of course, you remember that here the two halves are carrying the seeds, but here the seeds remain attached to one axis here, which is called false septum, or technically called as replum. So mustard, and a variation in of the siliqua is silicula, and this you will find in the capsula of Brassicaceae family. Only thing is that it is a short siliqua. So you can see that size here. So the siliqua, while it is long with the many seeds, and the silicula is short with few seeds. So you can call this as what? The few seeded siliqua is called silicula. And the capsules will have different features, and they break differently. So let us, I am briefing it, and this is what, okay, lady's finger, and this is a loculicidal capsule. Loculicidal capsule. And here I drew this one, that is papaver. That is papaver. And it is a porous capsule. So you can see here the pores are formed, pores, and through these pores the seeds will come out or dispersed. So that is what the dehiscent fruits. Okay, and when we come to indehiscent fruits, though this pericarp becomes dry, but the seeds will remain inside, and that's why they are called indehiscent. And we have four types here, achene, and this achene also generally seen among aggregate fruits, and one thing is that the seed, free seed, you will find here. This is free seed. And remember, all these indehiscent fruits are single seeded fruits. Okay, and the example for this is strawberry, and also lotus. Okay, that is what achene. And caryopsis is the characteristic fruit of the family Poaceae. And this also looks like achene, but with a difference is that the seed remains attached to the pericarp. This is pericarp. Okay, so poaceae members like what? Rice, wheat, okay, java, bajra, etc. They're all okay. Fruits are caryopsis. Cypsela. Cypsela is the characteristic fruit of the family Asteraceae. Okay, and there also this is seed, and the seed is free. But what is the characteristic feature of this fruit is presence of persistent calyx. But of course, this persistent calyx is in the form of hair, and it is called what? Pappus. So the single seeded fruit with pappus is called Cypsela. And in the family Asteraceae you will find like what? Sunflower, marigold, all of them they belong to this Asteraceae. And the nut, of course, you can see this one, that is cashew nut with the false fruit. This is false fruit, and this is the true fruit, which we are calling it as nut, and it is single seeded and free seed. Okay, inside you will find the seed, free seed. So the example for this is what? The cashew nut. Okay. Now, when we come to the schizocarpic fruits, these schizocarpic fruits will exhibit both dehiscent as well as indehiscent characters. That's why they are called schizocarpic. And we have four types here. The first one is lumentum, and this lumentum is the characteristic fruit of the family Mimosaceae. Of course, you heard about Mimosa pudica and acacia are important members of this family Mimosaceae. And this will have like this, and okay, and you will find some constrictions, and whenever it gets uh, dry up, it breaks like this in the constrictions. So some individual parts will be formed, and we call them as what? Mericarps, and these mericarps are single seeded, and the number of mericarps will depend on number of seeds. But remember that the seed, okay, is still covered with the pericarp. That's why breaking is decent character, and the seed remain surrounded by the pericarp is indecent character. So both characters you will find, and that is what about lumentum, and the examples are mimosa and acacia. And cremocarp is the characteristic fruit of the family Apiaceae. Apiaceae, and of course, we are familiar with the one that is coriander. So it breaks up into two mericarps and remain attached to a stalk called carpophore. So this is carpophore. Okay, so the example is coriander, and regma develops from tricarpellary, syncarpus, trilocular, superior ovary, and of course here it will break up into three mericarps, and the example is castor, and carcerulus is the characteristic fruit of the family, okay, Lamiaceae, Lamiaceae, and the example is okay, Tulsi, the sacred plant. So it breaks up into four mericarps, and each mericarp is single seeded. So like that, you will find these simple fruits, among which we discussed the two kinds so far, that is fleshy fruits and dry fruits. Okay, and dry fruits are of three types, that is dehiscent, indehiscent, and schizocarpic. Okay. So now let us discuss about the second category of fruits, aggregate fruits. And these aggregate fruits develop from Epocarpus gyraecium. Epocarpus gyraecium. So what is Epocarpus gyraecium? So the gyraecium with free carpels means these fruits develop from single flower, but the type of gyraecium is not syncarpus, it is Epocarpus gyraecium. And the nature of that's why here you will get what fruitlets, and because of the size they are called what fruitlets, and they appear in the form of okay cluster. Sometimes they appear like single fruit, and the best example is this custard apple, Ananas squamosa, that is the scientific name, and it is custard apple, that is sitafal. You know. And it looks like simple fruit, and whatever you are finding on the top is not pericarp, they are what stigmas, and all these stigmas are fused to make one single fruit. And when you open them you will find so many white colored fruits with black seeds, that each one is what a fruitlet. So they are berries, so that's why the cluster is called as etario. Here in aggregate fruits we use this word etario, that is a cluster. So it is an example for etaria of berries, custard apple. And some will show the characters of drupes, means what with stony endocarp, and they formed from one flower. You see, and the example is raspberry. So it area of drupes. Like that, if you take the achenes, already while discussing about achenes, I told you that these achenes generally found among aggregate fruits. So strawberry, but of course don't get confused. I mentioned the strawberry already under pseudocarp, because the achenes are the two fruits here, and the one which we are actually eating is thalamus. So the thalamus is forming false fruit, whereas achenes are the true fruits. So this is etaria of achenes, and etaria of follicles. You can see here. So this cluster didn't develop from many flowers. The cluster developed from single flower. So Epocarpus gyraecium. So magnolia is the example for that. So, but you have to be very careful. Don't forget the grapes. So people think that grapes also aggregate fruits. Not, no, 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 no. Grapes, that bunch is formed because of the inflorescence, and every flower in that inflorescence developed into a simple fruit. That's why you can check the examples which I mentioned under simple fruit. Grapes fall under berry, simple fleshy fruit. Okay, so now let us come to this multiple or composite fruit. The multiple or composite fruits are of two types: Sorosis, and the second one is Syconus. Sorosis and Syconus. And the Sorosis fruit may develop from spadix inflorescence, or it may develop from spike inflorescence. And the example for the Sorosis that developed from spadix inflorescence is jackfruit. And with that, this is not pericarp. Generally, we mistake this as what the fruit wall. It is not the fruit wall. So this is the rind, which is formed by the fusion of stigmas, just like Annona squamosa. But the thing is that Annona squamosa developed from single flower, but this one developed from inflorescence. And you will find inside so many fruits, yellow colored ones, they are fruitlets, and the one which we are eating is actually perianth. So the edible part in the jackfruit is perianth. Okay, and this is pineapple, and of course you can see here this is the bulbil. So which is used for vegetative propagation. So the fruit with bulbil is what pineapple, and it has developed from spike inflorescence, and these are all stigmas, okay, fusing to form what a single fruit, okay, and inside, of course, okay, you will find what uh, generally seedless pineapple. So seeds are not formed here, and except the rind, everything is generally edible. So that is what the Soros is. And when we come to the Syconus fruit develops from hypanthodium inflorescence. Hypanthodium inflorescence, and the example is fig or ficus. Ficus carica. Okay, so that is fig, and actually this is fleshy peduncle, and you will find here the fruits only at the base, and these are achenes, are the two fruits. So what is edible? Peduncle. The fleshy peduncle is edible. Fleshy peduncle is edible. It means what? That is also a false part or false fruit. So this is about the topic fruits.